Okay, no problem. So let we begin our today's class. So good afternoon all and welcome to SolidWorks online training program at SaiCad Center. And my name is Setu Nandania and I am a Autodesk PTC and Dassault certified instructor. And let we begin our class directly with the software. So here I am sharing my software screen. I hope this software screen is visible to you. Please confirm it once.
Yes, sir.
Yes, sir.
Visible.
Yes, sir.
Okay. Thank you. So take a new file, click on new, part file and hit OK. First of all, check your units. We are in mmgs millimeter gram second. And today we are going to learn the sweep tool and the loft tool. See, these both are very useful tool and we have a very unique application for this both. So here right now, first of all, these both tools are disabled, right? We are not able to access this. So why? Because this tool needs multiple sketches and we haven't any sketch yet. That's why this tools is disabled. So let me sketch first. So go to the sketch and here sketch on the front plane. And I am creating one spline over here. Okay, so this is a spline. Just finish it and go to the feature again. So here see we have sweep tool now activated. So click on sweep and here in the profile and path selection we have. So actually we need two sketches over here, profile sketch and path sketch. But we have only one sketch. So in the newer version of SolidWorks, like in 2017, from 2017, we have one more option over here, that is circular profile. If you are using older version of SolidWorks than 2017, you will not get this option, right? But that doesn't mean that you are not able to create a circular profile. You can create a sketch also, circular sketch, right? So choose circular profile over here. So here we have to select only single sketch. So I am selecting this spline as my sketch and here we need to provide a diameter for circle. Let's say 25.4. I want 1 inch diameter. So this is our output with this circular profile. And if you want a hollow section like tube, then go to the thin feature and provide your thickness over here. That 2.5 mm is my thickness. It should be inside or outside or both sides. So all the options we have, like we discuss in our extrusion and revolve tool, right? So click on OK and here is the output. So now I hope you in your all in your mind you are creating some kinds of object with the help of this sweep tool, because it's a very flexible tool, right? So you are thinking about that, yes, this type of things I can create with sweep tool, this type of things I can create with sweep tool, right? So we have many applications for this sweep. But let me discuss this tool in detail first. So here I am going to delete my sweep tool. So we have only path, and I'm creating one more sketch. So go to the sketch again, and I'm choosing a perpendicular plane. See, I'm choosing top plane over here. So perpendicular plane is must necessary for the sweep tool, because if you create both sketch in a single plane, then you are not able to sweep that geometry. So here we have, say, 30 mm by 20 mm rectangle, and finish it. See, my this rectangle is on other plane, and this spline is also on other plane, right? So this is perpendicular to my curve. Not exactly perpendicular, but it is not in the same plane. It's a perpendicular. So this type of two sketches you need to create a sweep profile. So click on sweep, go to the sketch profile option, and here I am selecting this rectangle as a sketch and this spline as a path. So in the path selection, select this. So you will get this output, right? Now look this thing from the front. So you will get the exact idea about sweep profile. So in the extrusion, our sketch is taking straight height. In the revolve, our sketch is taking a circular height, and in the sweep, our sketch is following a particular path, nothing else, right? So we can say that extrusion is a part of sweep, revolve is also a part of sweep. So sweep is the parent object. How did you choose that plane for sketch? Okay, I will show you. I took sketch tool. So click on the create sketch, and then I need that top plane right now, but it is not visible. So I go to my feature manager tree over here, where we have front, top, and right. Our standard planes are here. So from here I choose this top plane and then press Ctrl 8 and create that rectangle. Right? But I have one question, and that is, are you agree with me that extrusion is also a part of sweep geometry and revolve is also a part of sweep geometry? Say yes or no.
Yes, sir, we can do.
Yes, sir. Yes.
Good. So you all get my point that how we can perform that thing, right?
Sir, can you tell about revolve again, sir?
Revolve tool. Okay, sure.
Yes, sir. Revolve is a part of sweep you're telling. So can you tell it?
Yes, I can prove it. See, just a minute. I will give you an example for each and every one. So this is my first example. For example, I'm sketching one line on the front plane of 100 mm, finish, and I am creating one more sketch on the top plane. Please mute yourself. And here we have a sketch, for example 150 and 70 mm, and finish. Now see, this is our profile, this is our path. So you can use sweep tool, sweep, this is my sketch and this is my path, and you will get a result like extrusion. Okay, now again take extrusion tool and just select sketch and provide value over here 100 mm. Again we have same result. So extrusion is a part of sweep, we can say, because all the types of extruded geometry we are also able to create with the help of sweep tool. Just your path is a straight line, nothing else, right? Similarly, if we are discussing about revolve tool, right? So let me delete this sketch. Please mute yourself. Okay, thank you. So for the revolve, let me edit this sketch, edit, control it, and I'm creating a revolving axis over here. So for construction, and this is my revolve axis, right? Smart dimension, let's say 200. So this is my revolving axis and finish. So here I am going to revolve this sketch around this axis. Let's say 90 degree. I want to revolve 90 degree. So this is my revolving result, right? So this is revolve tool, but we also can achieve this shape with the sweep. For that we have to create path, that circular path like that. So we will use front plane, create sketch, control it. Our center will be over here. So I am placing my center, this center point right on this line. Okay. And how much revolutions we want? If you want 360, you can use full circle. If you want 90 degree, so let me create a half circle over here. So one more line for construction. I just want 90 degree revolution. So I have created a 90 degree circle over here. One more construction line, we need a horizontal like this, and then trim this rest portion, right? So this is our path, this is our profile. Go to the sweep, path profile is this one and path is this one. So you will get same result like revolve. So I hope now you are agree with me that revolve and sweep is a part of extrusion and revolve is a part of sweep, right?
Yes, sir.
So this all geometry is known as sweepable body. We can say it's a sweepable body. Whenever you follow any cross section to any path, either it's a straight path, then we can say it's a extrusion. If your path is circular, then we can say it's a revolve. But if your path is zigzag, like any other path, spline or any other curves or anything, then we can say it's a sweep. But everything is a sweep for me. So I hope this thing is clear now. Okay, so let me continue our sweep tool. So here we have a zigzag path, a spline path. So this profile will follow this path. So that is our sweep tool. So click on sweep, my sketch is this one, path is this one, and it is following this path. But to follow the path, we have two options over here. Take it in front. If you go to the options, in the follow path, we have two options. We have follow path and we have keep normal constant. So let me discuss about keep normal constant. So take this and you will notice that our middle portion is shrink down little bit, right? Why it is? Because in this condition our profile is not following the path. Our profile is not taking angle, or our profile is not going to change its angle. That means, just let me annotate for you. See, here I am annotating our profile's position at each and every point. So at the starting position we have a profile in like this, right? At this position it will remain, the orientation of our profile will always remain horizontal. See, like this. So this option is known as keep normal constant. So our profile will never change its angle. It will remain in whatever angle it is. So it will remain in this condition up to the end. That's why we are getting a a thin profile over here, because our profile is horizontal, right? So understood? This green lines is representing our profile position, our profile's orientation of our rectangle. But when you choose follow path option, so what will happen? Whenever your path is going to bend, your profile is also bending. See, not this one. Let me take line. Okay. See, here we have at this position, then here, then here. So as our curve is going to bend, our part or our profile is also change its angle. So in this case you will get a uniform thickness at all position, right? So these are the two options we have: follow path and keep normal constant. And also we discuss about thin feature, right? To get a thickness part or thin feature part, you can use this thin feature option. Also we have twist option. So again sweep this rectangle on this path, so it's just going to sweep like this. But in the options we have profile twist option over here. So turn on this profile twist, take a specified twist value and provide your value over here. So let's say 90 degree. So you will get this type of thing. Our profile, see, this is our profile, this rectangle is our profile, and this curve is our path. So our profile will rotate along this path. Our profile will rotate along this path. How much? 90 degree, while completing this path. See, at the beginning we have horizontal rectangle, and at the end we have vertical rectangle. That means my rectangle rotates 90 degree. So you will get a twisted geometry like this. That's why this tool is twist profile. So you will get this type of twisted geometry. you can provide any angle over here. For example, I want one revolution 360, I want two revolution, you can type 720, right? Or if you don't want to provide a degrees, you can use revolution option also, that I want 1.5 revolution, hit OK. So this is your twisted geometry. So these are the options we have that is not available in extrusion and revolve, right? So that are the child tool we have of our sweep geometry. So I hope sweep tool is clear now. Similarly, we have a sweep
Yes,
cut,
sir.
right? Similarly, we have sweep cut, and this tool is used for cutting profile. Like extrusion cut, like revolve cut, we have sweep cut tool. Repeat what I need to repeat. Last one. Okay. Okay, last step. I am showing you my last step in the sweep cut profile. See, so both the things is going to cover. So here I am creating one object by extrusion over here. Finish it and extrude it. Okay. Now see, we have a profile and path, but this time I am using sweep cut tool. So click on sweep cut. We have same operations over here. Select your profile, select your path, and at the end you will get a sweep cut over here. When you finish this, you will get a cut over there. That is our sweep cut, and just edit it. And here in the options we have profile twist option. If you want to twist your profile along your path, just turn on or go to the twist profile, click the specified twist value, and here you can provide your degree, or if you want to provide number of revolution, then take revolution instead of degree. So here you can provide your revolutions, that I want one revolution while finishing my path, so it will take one complete revolution. If you type 2, it will take 2 revolutions, right? So these are the revolutions we have. Then hit enter. Okay, so you will get that type of geometry over here. Now it is clear.
Yes, sir.
Yes, sir.
Okay, good. So next tool we have is a loft, and before we discuss about loft, we need to discuss about a reference geometry. So let we have a look about reference geometry. So with the help of reference geometry, we can create a new planes, new axes, coordinate systems, and also points. Right now or mostly we need only planes. Axis that we can create with the help of center line also, right? Coordinates generally we don't need mostly, so we just need, or we have to focus only on plane. And there are many options to create a plane. See, I am showing you whatever options I have. So click on the plane, it will create a new plane, and you all know why we have to create plane, right? We create planes to create a sketch, right? So without plane we are not able to create sketch also. So for that we need plane. So first of all, we have a single reference plane. In that you will get a offset plane. So select any flat face or select any existing plane to get offset plane, right? So I am selecting this face and you will get one plane at some distance. So distance you can type over here that I want plane at 50 mm. So you will get one new plane. Hit OK, and now we are able to sketch on this also. See, standard we have three planes available. I am just unhiding that. So we have top, front and right? And also we have created this new one, plane 1. So we can sketch on this plane also. Then other options for the plane creation. Yes, you can. Now
Can you
see
explain plane creation once again, sir?
what
Can
plane.
you explain plane creation once again, sir? Please?
Yes, we have many options in the plane creation. I am showing you. So go to the reference geometry, click on planes, and if you select a single face, then simply you will get a offset plane. Offset value type over here that I want 50 mm, or if you want to flip the direction on the other side or on this side, right? So in this way you can create your new plane. But mainly we have many methods to create plane. See, for example, you need a angle plane or a plane through two axes or plane through 3 points. So these are the planes we have. So go to the plane, and over here we have maximum 3 references available. So we can provide maximum 3 references, right? Reference 1, reference 2 and reference 3. If you select any face, then we have our first option, offset plane, and over here you will see fully defined. That means you are okay to hit OK. But instead of this distance I am choosing perpendicular. So see, we are not ready to finish this tool right now. We choose a perpendicular, but we need a second reference over here. So I am choosing for example this line. So I have one plane which is perpendicular with this plane and passing from this line, right? So here we provide 2 references. So quickly let me show you all the options. So go to the plane, first select a face, and then in the second reference select one edge, right? And then go to the perpendicular, you will get 90-degree angle plane. Go to the angle option and you can provide angle plane over here, that I want a plane at 45-degree. So you will get one plane which is passing from this edge and having a angle from your selected face with a 45-degree. If you want to flip your angle, you can flip it like this, right? So this is our angle plane, this is our offset plane, this is our perpendicular plane. Hit OK. Then we have next option, plane, and select two edges. two parallel edges, for example this one and selecting this one, so you will get one plane passing from both the edges. Then third option we have is passing from 3 points. Let me hide some over here. See, we don't need all these options. We generally prefer offset plane only. And one more option we have that are enough for us, but I'm showing you all the options. So plane, we discuss about single reference, we discuss about two reference. Now we have a example for three reference. So for three reference, I'm selecting this point, and this point. So as you all know that we can define a plane from three non-collinear points, right? So this is an example of three reference. So in this way you can create your planes. These are the options we have for the plane creation purpose. Yes. Okay. So let we continue our loft tool, right? So here I have to create a multiple sketches, and to create a multiple sketches I need some planes. So just turn on this top plane so you can view it properly. And I am also creating two parallel planes over here. So go to the reference geometry plane, select this plane at say 50 mm, and I need two planes. So here we have linear pattern, see, for the offset plane. So type 2 over here, hit OK. So we have two parallel planes over here with the top plane, right, at 50 mm 50 mm gap. So I am creating one sketch. So click on sketch on the top plane, and here I am creating one polygon of some dimensions, let's say 75 mm diameter. Finish. So this sketch is on top plane. Now again I'm creating one more sketch. So click on sketch again, but this time I'm creating on the front plane, sorry, plane 1, control 8. And here I want one circle, tiny circle, not much bigger, let's say 25 mm. Finish. And then one more sketch. So again sketch on the plane number 2, control 8, and here I am creating let's say ellipse. We are creating one ellipse over here. This should be 70 mm, and this should be 30 mm. Okay, fine. Finish. So here we have three sketches at some gaps, right? Again hide this plane. Now we don't need these planes, so hide it, don't delete it. If you are going to delete your plane, your sketch will also going to delete, because the sketch is dependent on this plane, right? The sketch is dependent on your subsequent plane. So if you delete your plane, your sketch will also going to delete. So here we have our loft tool. So go to the loft boss and select your profiles in a proper sequence. So this is my first profile, this is my second profile, and this is my third profile, and hit OK. You will get this type of solid geometry using these three cross sections. So it is clear how this loft function works.
Yes, sir.
Good. So with the help of loft, we can create a solid of multiple cross sections. See, if you see the section view from the top plane, okay. So at the initial point we have a hexagonal section. Then as you go up, our section will become circular at 50 mm. Then as you go up, our section will become elliptical. Right? So we have three cross sections over here. So this is our loft tool. And similarly we have lofted cut. Also we have option for thin feature like x2 loft, this profile and this profile, and here we have thin feature. So if you want a part with some thickness, then get it from here. Right? Okay. So now let me discuss this loft tool in detail. So I'm deleting these sketches and creating a very simple sketch on the top plane. Let's have a corner rectangle only, right? Around 100 by 200. Finish. And on the plane number 1, that means on the 50 mm above, we have another sketch. And here again I am creating a corner rectangle with the dimension 50 mm by 100 mm. Finish. Right? So we have two sketches over here. And as you all know that we use loft tool, and if we connect this edge with this one, you will get this type of preview, right? So this corner is connect over here, this corner will connect here, subsequently all the others are connected. But for example, I am changing my profile over here. See, I am clicking on this green button and dragging to the other corner. See, this point or this vertex connects over here. So subsequently this will go there, this will go there, and this will come up here. If you turn it again, so we have a zero thickness solid over here because we are not able to connect this point directly over here and this point directly over here. So we have zero thickness solid at the center. That's why we have error. So here is the result, and here we are back to original, right? But once, see, I am taking this point over here and I am going to finish this. Hit OK. So we have this twisted geometry over here, right? Again, I am going to edit it. So now I am not able to take this point back, or if I take this point back, all the other point will remain as it is. See, I am taking this point again back here, but this point is still connected over here, this point is still connected over here, and this point is also connected over here, right? So you will mismatch your geometry like this. So before you finish, make sure each and everything is fine, then finish your geometry. Then next we have some guide curves. So I hope you clear about the twisting profile. Okay. So now I'm going to teach you about the guide curves. Guide curves are that curves by which your all cross section, we can connect your all cross section, right? So for that we need that type of plane who is passing from your all cross sections. Right now we have only two cross section, and we have started both the cross section from the origin, right? So this point and this point is on origin. So we have this front plane over here where we can get a common point of both. So I'm choosing front plane, create sketch, control 8, and here I'm creating one arc. First create arc over here at some distance, and then orbit it a little bit and connect a point properly. So press Ctrl, select this point and hit coincident. Same over here, this point, Ctrl and this point, and hit coincident. If you want coincide your object properly, then your guide curve will not work. So for example, you have three cross section, your curve must be in contact or coincide with all your three profile, or if you have four profile, then four profile, right? So your curve must be properly connect. And dimension, let's say 35, and finish. So here I have create one curve like this that connects this point to this point by this path. Okay, now go to the loft. Here profile number 1 is this, profile number 2 is this, and in the guide curves I am providing this curve. So instead of going straight, we will follow this curve. Due to that, we have a little curvature effect on the other side also. Hit OK. So you will get this type of geometry. Again delete it. Let me create one more guide curve. So on the front plane, again sketch, control 8, and on this side I want a spline. So I'm creating a 4-point spline over here, and this point coincide with this one. This point will coincide with this one. Okay. Again control 8 and make sure your curve is proper. I want something like this. Okay, finish it. So we have one more curve on this side. So again go to the loft, select your first profile, second profile, go to the guide curves, select your first guide curve, select your other guide curve. If a solution is there in front of you in yellow color, then you are okay. Yes, actually I haven't. I just create a underdefined sketch, that's plain. So in this way you can add as many guide curves as you want, right? But SolidWorks will accept your all guide curves. Still he can, right? Once he will give you some error, then it will be your error. For example, I want to add one more guide curve over here. I want to connect this both point with a straight line, right? So delete this, and here we have a right plane which is passing from this both point. I'm choosing this right plane, control it, and I want a straight line over there. So as I told you, create a line or any object at some distance, then connect it manually by yourself. So there are minimum chance or minimum error will be there, connectivity error, right? Now let me create one more curve, a straight curve I want from this point to this point. So from the curves you can create also. Here we have a option curve through XYZ point or curve through reference point. So let me click on the curve through reference point, and my first reference point is this and second reference point is this. So we have this straight line, that's it. So we added 4 guide curves over here, right? Now let me check our result, what we are getting. So loft, first profile, second profile, not like this. Okay, so make sure your selection is proper. Now in the guide curve I'm selecting this curve. Okay, good, we have result. This one, still we have result. This one, still we are getting result. This one. So yes, we have a perfect output as per our requirement. If State Pro stops showing you a preview, that means there is error, right? So this is our Loft tool. Now let me discuss some more options in the Loft tool. So clear up to this point about the guide curves. You can add as many guide curves as you want. Hello students, am I audible or not?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
So today's session might be a little boring, right? Say yes, sir.
No, sir.
Okay, then okay. Now see, it's actually there are so many things inside this single tool. That's why I'm going very slowly. Otherwise, it will create confusion in your mind. So first we discuss about how to connect all the cross section. Then in the second step I discuss about that twisting profile. Then in the third step I discuss about guide curves. Now the next we are going to discuss about starting and ending profile, right? So delete this all thing with the sketches. So if you want to delete your object with sketches, then turn on this delete absorbed feature, then hit OK. So your sketches are also deleted. On the top plane I'm creating one sketch. Uh, 75 mm diameter circle, finish. On the plane 1 I'm creating one more sketch. Mm, 35 mm diameter circle, and on the plane number 2 sketch, control 8, and let's say again 75 diameter circle, or you can use this projection also. See, this convert entities is our projection, right? So click on convert entities and you can take projection of any sketch or solid object. Just select that and hit OK. You will get a projection of that object on your plane. Ultimately you will get one sketch, right? So this is our projection. So you can create projection also. Okay, now go to the loft, select first profile, second profile, and third profile. Now what will happen over here? Actually we have created a circular profile. That is why we do not have a proper corner point. So our this joining point can rest at any position. No, you cannot change the dimension until you delete that relation. So due to this thing our profile is going to twist. See, this point is connected over here and then this point is connected at this position. That's why we have a little twisted profile over here. Once you finish it, it will be not visible for you because we do not have edges over here. But I want a perfectly straight profile. So what will I do? I will go to particular view and take this point like this on the side, like this, all the points at side. Okay, good. So now we have a straight connection. We have thin feature option also that we discuss, right?
Excuse me, sir.
Yes.
What is that point, sir, that you have shifted to the end?
This,
Yeah, yes, sir. What is that? Why is that being shifted?
it's your gripping point. I discuss about the twisting profile, right? Do you know about
Okay.
twisting profile that we discussed initially at the beginning of the
Yeah, yes,
session?
yes.
Yes. So
Yes,
same
sir.
way, this is our beginning point. You can say this point of this sketch is connected over here, then this point is connected over here. If I switch my this point over here, so see we have a twisted profile. So
Yes,
this point is actually connecting right here and then here. So this is my twisted
okay.
geometry, right? That is why I took a particular view and take all this starting point at particular position like this. So we do not have a twisted geometry.
Okay, sir.
So again, loft, selecting this profile, and this profile. Now from the front view, take it to the side. Okay. And generally, our profiles are connecting tangentially. See, starting from here, a curvature effect, then go straight to the here. So for the starting profile and for the ending profile, we do not have any kind of setting. For the other profiles, like over here at the center, we have a perfect tangency effect. See, but our starting position is not connected with the other profile. That's why we have not a proper effect over here. So if you want to provide some constraint to your starting profile and your ending profile, so we have a start and end constraints over here. So go to the start and end constraint. For the start constraint, I want to provide a tangency direction. Say I am choosing my front view and I want my starting profile should be start from here like this. It start from like this, perpendicular with my plane, right? Instead of this way, I want my initial profile starting like this, right? So I want to change the starting direction. So here we have start constraint. So here I am choosing direction vector, or you can use normal to profile. So let me say direction vector, and I am choosing top plane is my direction. So see, we have one vector over here, and if you view it from this view, so you will notice that instead of going like this, before we are going like this, right? Now we are starting tangentially or perpendicular from our sketch. So this is our starting constraint. Similarly, we can provide a ending constraint. Say here we have end constraints. So again, normal to profile. So see, it is again normal with the profile. So this is our starting and ending constraints we have. Now you can provide further angle also. See, in the start direction, I don't need this 0 degree angle. Let me increase that degree. So let's say 30 degree. So instead of this vertical, my curve is starting at 30 degree angle like this, at this angle. My profile is going to start, right? And this thing is known as tangency effect. So if you increase your tangency effect, your curvature, your tangency effect will be go up to the far distance. See, as I increase this, my effect will carry at some distance. So as you increase this thing, your tangency of that curve will increase with this angle, right? Let's say 25 degree. So with this angle, this tangency effect I want to carry up to 3.5. So this is just a value. We do not have a particular unit or anything. This thing will depend on your requirement. Same for the top side, we can provide a negative angle like going inside. 20 degree or more, 30 degree, and its tangents effect, .5. So in this way you can create your complex geometry. We have many facilities available in the loft feature. So I hope what is our input, and as you all notice that what is our output. There is no relation between our sketch and our created geometry, right?
Yes, sir.
Yes, sir.
Sir, if we give a rectangle or other instead of circle at mid plane, it come correct projection. Sir, yes, you will get a projection of anything, my friend. You can take projection of a solid object also. This edges, whatever edges you have, you can take a projection of that edges, and also a sketch. You can take projection of anything. So this is start and end constraint. Now the next option we have is close loft. Close loft is actually going to connect your loft profile. So for example, let we create something new for that. So delete this thing. Now on the front plane, I'm creating one sketch, circle. Let's say, what should we take? Diameter 50 mm, 70 mm. Okay, good. Let's say 70 mm. And gap from the center, 150 mm we are taking. Okay. Again on the front plane, one more sketch. This is our second sketch, and creating one more circle of 50 mm, and it again 150 mm distance. Finish. So we have two sketches over here. Same on the right plane, I am creating sketch. Control 8. Let me create one ellipse. Dimension center point is 150 mm fix. This should be 70 by 50. No, 80 by 40. Good. This point and this point horizontal, and this is also horizontal. Finish. And one more sketch on the right plane again, but this time we will draw over here. a vertical ellipse. Dimensions 150, vertical dimension 80, and horizontal dimension 40. This point, and this point, all these points are horizontal. Okay, done. So we have fully defined sketch. Now see, if you want to connect all this profile, and if you want to create a lofted geometry, right? So go to the loft, select your first profile, then second profile, then third, then fourth, and again you are not able to select your first profile. It will deselect your profile, right? So if you want to close this thing, we have option over here. In the options we have close loft option. It will close your entire loop like this. Take a front view and take all these points on the top. So we do not have a twisted profile. And okay. But do you like this? This shape is not that much cool, right? Why? Because it's not properly circular, right? So for that, if you want to add a particular guide curve, see, we are not able to add guide curve over here because guide curve is actually connecting your profile to profile, right? From this edge to edge you can create a guide curve, from this point to this point you can create a guide curve, right? But here I want to create one sketch from center to center to center and want to connect it properly with a circular pattern. So I am choosing this top plane and creating one circle because we take 150 mm radius or 150 mm gap at every object. So 300. See, this circle is actually passing from the center of all these three profiles, right? So that's why I have created all these four profiles at 150 mm gap from the origin. But we cannot use this sketch as our guide curve. See, this curve is actually passing from the center. So we cannot use this curve as a guide curve. Right? Guide curve must be passed from your profile and in every profile. But this sketch we can say it's a center line curve. What we can say? Center line curve. So again go to the loft. We are selecting this profile, this profile, this profile and this profile. And to close it we are using this close loft tool, right? But this is not properly circular. So for the to provide a spine, a proper direction, we have a center line parameter over here. So turn on this center line parameter and provide this center line curve. So now your object will perfectly follow that path. So now it's look perfectly circular, right? And hit OK. Now you may like this thing because it's in a proper shape. So these are the options we have in the loft, and the same option also available in the loft cut. So clear it is?
Yes, sir.
Yes, sir.
Yes, sir.
Good. Any confusion?
No, sir.
Okay. So here I'm going to show you your next assignment. See, this is your next assignment. One thing is there we haven't discussed yet, right? So our learning portion is not finished yet. We have lots of things still we need to discuss, right? So just for a tiny break for your mind. So here we discuss assignment first, then we will again continue our session. So in your assignment you have to create one shape like this. It's like chimta. Okay, whatever it is, just create one path and create a sketch and sweep it, right? Then we have this one. So you have to create this object without sweep. So you have to create this object without sweep. Okay, this is a special conditions I am applying on the objects. I hope this assignment is visible.
Yes, sir.
Okay.
Yes, sir.
Yes, sir. Yes, sir.
So if you have any kind of confusion, you can immediately ask me. Okay. So this object, I am adding some restrictions to you. You have not, or you should not use sweep tool to create this profile, right? You have to manage your work with the other tools. Then next we have this geometry. So it is fine. How you will create this geometry?
Create
Helical
a
shapes.
helix path and sweep.
So first we have to create helix, right?
Yes.
Okay. But here we have one restrictions. You are not allowed to use helix. So yes, you are right. We can use twist profile of the sweep profile to create this. I will show you how to create without helix. No, loft and twist will not work over here. Loft and twist will not work over here. Okay. Then next, this is actually an industrial component, right? When you go to the industries or companies, you will find this type of object over there. So just accept this fillet. See these tiny fillets you have, just ignore that fillet and create the rest of the part. You have to use sweep tool over here, right? And you will get the solution. And this one more, I think it's a centrifugal blower body. Okay, whatever. But we have a proper dimensioning over here. So just create it. So here you have to use extrusion, revolve, blend, right? All that tool. And for this assignment, you will need one more help, that is our shell command. So let me teach you that shell command because you will need that. So in this loft feature, I'm just going to deselect this close loft option and OK. So we have a solid geometry over here, right? And for example, I want to convert this solid into a thickness geometry in some thickness. SolidWorks screen is visible.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So for that we have a shell command. So go to this shell. Here you have to provide a thickness of geometry. Let's say 2.5 mm I want. And here you have to select which face you want to remove. So your removing face should be over here. So I want to remove this face and this face. Okay, and finish. So the rest face, that means we have only one face over here. So this face will take 2.5 mm thickness and we have a hollow part for that. So this shell command will help you to create that blower geometry, right? That last option that we discussed. You will need a help of this shell tool. So first create a complete solid and at the end shell it. So your all the internal volume will be removed and you will get a hollow geometry like this. This type of hollow geometry you will get. Okay, now let me discuss Helix. To create Helix, go to the curves. Here we have Helix and spiral option. So click on the Helix. Choose your plane to sketch and create one circle with proper dimensions. Let's say 100 mm diameter. Finish it. As you go finish that circle, your circle will going to take height and create one helix. And we have so many options over here like pitch and revolution, height and revolution, height and pitch, or spiral option. So if you want a spiral spring like this, let me increase this revolution so you will get the idea. So this is our spiral spring. So you can use spiral or just try to prefer this pitch and revolution. It is easiest for us. So pitch over here, I want pitch 40 mm. Actually in our problem, what is given to us? It's a helical height and helix pitch. Okay, so we have pitch and height. So choose that height and pitch option. Our height is 250 mm and pitch is 40 mm. So number of revolution will automatically decide. Starting angle, let's say 0 and hit OK. So here we have a coil. Now just simply go to the sweep, select circular profile and select your path and you will get a result. Now the hole diameter is 12.5 mm and the thin feature of 5 mm, and that is inside or outside, I don't know. Just finish it. Then hide this spiral tool and you will get this in your result. Right? Now I am showing you with the only sweep tool. So for that, first of all, we need to count the number of revolution. We have 12.5 mm radius. Okay, so just edit it and 12.5 into 2. I don't use to type 25. Enter. So this thickness will be inside. Right? What is the difference between thin feature and shell? Nothing. Thin feature is also creating the same thing. But for example, see, we have created this thing, right? And now after doing this thing, I want to create something else. Like I want to do extrusion. So extrusion on this face, I'm creating one circle like this. Okay. And going to extrude it up to certain limit. Then okay. Then here I am going to create something else like let's say one reference geometry. Okay, just again extrude it here, circle, circle, this much, finish. And this time I want a draft angle of 10 degree, finish, right? And then something, we have other things over here. So at that time, if you use your thin feature, then your coil will be there with the hollow section. But you have to manage your hollow section in this extrusion also, in this extrusion also. This will be a difficult task for you. So once you create your complete geometry, then at the end you can shell it to convert it into a thickness. Now say 5 mm and I don't need this face, and on the other side I don't need this face. Hit OK. So here we have a continuous shell object. If you use thin feature, you will get a hollow object only this much. Then the rest of the thing you have to manage. So you have to manage that thing at each and every operation. This is just two operation I have done over here. But for example, we have some other things also there with the same thickness. So it is better to make it hollow at the end. So let me create this coil with our twist profile tool. So for that, do one thing, divide 250 by 40 mm. Sketch on front plane. Here I am creating one line and dimension is 250. Please divide 250 by 40 and give me answer. So 6.25. Okay. So I have created one line of 250 mm. Now again on the same plane I am creating one more sketch, that is our circle. So what will happen, we are not able to sweep that profile because our both sketches are on the same plane or in same plane. That's why 50 and 25, right? Now finish this thing. Now if I'm going to sweep, see sweep, this is my profile and this is my path. So I will not get any output over here. But if we go to options and on the twist profile and here take twist value and provide some twisting over here like this. So as I told you, we always take a twist along our path. So if you provide 360 over here, our profile, our cross section will take a 360-degree revolution along the path, around the path, right? So path will be a center for this twisting thing. So here our total height is 250 mm and we have a pitch, that means for one revolution we have 40 mm. So we divide 250 by 40, so total we have 6.25. so this is 6.25 is our number of revolutions. So go to the revolutions and say 6.25 revolutions. So here we have our coil. Thin feature 5 mm inside. Okay. But there is a small gap between our previous method and this method that you have to find out, right? And one last thing, yes, see, whenever you create a random curve like this, for example on the top plane we are creating a curve. Are you there or not? Hello?
Yes,
Yes,
sir.
sir.
Okay. So see here I have created one random curve and finish it. Now I want to use this curve as a sweep profile, and I need one plane to create a profile sketch. This is my path and I need one plane for the profile sketch, but I do not have any perpendicular plane right now. See, I have this top plane, front and right plane, but I am not able to use this plane right now. This top plane is useless for me. This right plane is at not proper position. This front plane is also not at proper position. I need a perpendicular plane with this curve. So how to create a perpendicular plane to curve? We have one more option in the reference geometry. So go to the reference geometry, click on plane. Over here in the first reference, provide your curve. So it will create one plane because it's a 2D curve. And in the second reference, select one point. So this plane is perpendicular with this curve at this point. Hit OK. Right? So here we can create our sketch. Sketch on this plane. Control it. And let's say hexagon. I think it's a little big. Now for example, you want to add some more cross sections over here, like instead of sweep, now you change your mind and I want to create a lofted geometry over here along this path, right? So create more planes like this plane on this curve at this point. So again, this is also a perpendicular plane. Okay, and you can sketch a new profile over there. Control 8, and your this origin is over here, right? As you can see. So let we have a circle. Select it and put it at 0 0. The dimension 50 mm. Finish. Then at the end again we want one more section. So again reference geometry plane on this curve at this point. So can we add a point on curve? Yes, you can. Here we will create a slot. $75. 25. Finish. Now hide your planes and you have this geometry ready. You can loft it, you can sweep it. right? So these are the examples. How to add points on curves. So for that, just edit your sketch, right click and edit your sketch, control it, and here with the help of this point button you can add points on your curve. Like I want to create one section over here, so add the point over there, one section over here, so add point over here and finish it. Then you can use that point to create your plane, right? So these are the options we have. I hope you all are clear now about sweep tool, loft tool, also have some idea about shell tool. We will discuss this shell tool in detail whenever it comes in our syllabus, but I have just give you an overview and general idea about sweep tool. So please practice it, right? Otherwise you will feel that yes, it is too simple, I know, I understood properly, I will do that, but it will remains as it is. I will do that. I am not able to do that. You have to say that. Okay, that I am able to do that. Right? And that's come after the practice. So you have to practice it. So anyone have question? Okay, just a minute. I am taking your attendance. Right? And you can follow us on YouTube also. Are you following?
Yes, sir.
Good.
Yes, sir.
We will
Sir.
upload many videos over there. Initially you will get that introductory videos on the YouTube, right? But step by step, after 10 days or 5 days or a week, you will get the other videos also. Yes?
Yes, sir, we are getting it.
Okay. Is there any question?
No, sir.
Okay, good. So I'm going to end this call now, right? And see you on
Thank you so much,
Tuesday.
sir.
Yes? Anybody have question? So our next
Not
class
at
is
all.
on Tuesday, right? 19th of May. So see you in the next day. Bye.
Thank you,
Bye,
sir.
sir. Bye, sir. Thank you.
Bye, sir.
Okay.